So here's some examples, and they're mixed examples. And mixed examples are going to require you to do the order of operations. So I'm going to remind you, the order of operations is grouping symbol is last, exponents and logarithms are second from left to right, multiplication and division are third from left to right, and the last one is addition and subtraction from left to right. And this is how we would expand. But we are going, sorry, this is how we would condense, but we are going to expand. So we're actually going to do it in reverse, very similar to the way that you would solve. There obviously are solving connections of this later. But what I mean by that is if we see a multiplication sign here, that's going to go before this exponent right here because we're doing it in reverse, just like we would solve. So that multiplication sign would become a addition sign. So notice I see two things inside, so I'm going to write this down twice. X is first, and then y to the third is second. And then the next thing, since we did the addition, we're now going to do the multiplication. You could also think of it as we did the multiplication, and now we're going to do the exponent. Either way, you're going to get to the right answer. There is an interesting relationship there with exponents and multiplication and addition, because logarithms are really a form of exponentials. So just keep that in mind. All right, so there's your final answer. That's a terrible looking one. I'm going to fix it. All right. So not hard. You just have to think about the order in which you're doing it. All right. So let's take a look at the next one. So this one has division and two exponents. So the division, which is subtraction, is going to come before the two exponents. So first thing I see is that there are two things separated by subtraction. All right. That is a m cubed, and this is an n to the 7th, right? So there we go. And then I will move both of these out to the front as my last step. So not very hard. Again, some students actually don't do super well on this because they don't take it as seriously as they need to. Maybe they don't write the order of operations on their paper. It's important to just go in order. So down here we have a similar situation where this root right here is really a 1/2 power. And one of the things I'm going to remind you of is that 1/2 power goes out here. So when we think about that, in this case, we could put it in here, but that's actually going to cause it to be more complicated. So if you have an exponent on a single variable, you're going to do that after you add or subtract. But if you have it out here, think of this as like being outside the whole problem. So we're going to yank that out first, then this is the one we'll do last. So that'll come out as 1/2 log, okay, a cubed times b. And there's two ways to do this. You could then break this up with two addition signs, which is perfectly fine, but we have another exponent, so that gets a little complicated. So we're now going to basically think like this is in a parentheses. So that will now give us this. And then inside the parentheses, that multiplication will become an addition sign with log a cubed here, and then log b here. Okay, so let me go over what I did. I moved this out so it wouldn't overcomplicate the problem. Then I put this into parentheses because I have another exponent that I need to take out here. And then I broke up the addition and the multiplication into addition. Let me show you what the final answer is. And there is another answer that I'll talk about in just a second. This one looks the least complicated. I mean, hypothetically, you could distribute the 1/2 in, which you could have done right here, and this could be 3/2 and 1/2. They're both the same. So if you ever saw the other answer where this was 3/2 and that was 1/2, which would have come from the beginning here, it is the same as this answer. They're both correct. It's just kind of style in this case. Again, the style for this one, since I already have an exponent, I could put this in both of these, but then I'd have to factor it out. That's sort of our point. Like if I put this in here, there would be a factoring of having to remove it. So this is the cleanest way to do it, as opposed to if I distributed this in here, then there'd be a 1/2 in here that I would then have to GCF out. So to avoid GCFing, we just, hey, they kind of gave it to us. So we're just going to put it right there in the front. All right, giving us this. And then, of course, division means subtraction. So I'm going to leave this in a parentheses with the division means subtraction. But now I'm going to make sure I write log 4 down twice. And again, the reason I do that first is many students forget to write it on the second thing for some reason. The numerator always goes first. The denominator goes second. Remember, negative exponents are negative, so the denominators are negative. And then your last thing is to then put this out here. So why did I not keep going? Again, it causes a GCF, and those GCFs would cause you to have to do more work at the end. So this is the cleanest way to do it without having to then at the end look at it and say, hey, can I remove something else? Why can't I take the 2 out? Because there's no 2 there. Remember, GCFs would have to have on both. All right, here are our last 2 very similar problems, especially number 14. So just kind of hammer home this idea that this goes in the front. Again, why didn't we distribute it in? Because then we would have to take it out. So, just kind of saving you some time. This one's a little different because we do have a number, a normal integer, not just an exponent on a variable. Please keep in mind that there is a multiplication sign here, so there will be 3 ln's in my answer. Super big hint to write that down before you start. The 5 goes here. The p cubed goes here. And then the q to the 4th power goes here. And then the exponents would go in front. That would go there, and that would go there. Now, as I'm writing this answer out, it is important to understand that you can have exponents even on numbers. So we've seen a lot of examples here where the exponents are on the letters. However, hypothetically, let me finish writing that. If this was a 25, then there would be a 2 in the front there, right? Because 25 would be 5 squared. Just keep in mind that's something that students sometimes forget to do. And I just wanted to show it to you in case it pops up. Okay, so our last one, we got a lot going on here, but focus on the division and the fact that that's just an exponent, right? So I'm going to rewrite this first by just saying, okay, well, this is really x to the 1/3. Okay, and so I'm going to have log base 2 of x to the 1/3. That's the numerator. And then I'm going to subtract the denominator. Now, some students will look at that and say, well, what's going on there? Well, let's take a look at this part. And I just want you to look at it and ask yourself, kind of comes back. We saw one of the example in our notes. Does that addition sign, a lot of kids would say this was the answer once they did this, right? So they move this to the front. The question here is always ask yourself, when I give you an addition sign of variables, can it be factored? And in fact, this has a GCF of x. So if you were to take out the x with division, you could rewrite this as log x times x plus 1. And remember, in the world of logs, that multiplication sign is an addition sign. So let's take a look at what that looks like. And remember, when you have anything on the front of something, we've been focusing on it as its own problem here. Anything on the front produces a parentheses. Notice I have it on these problems. So this is really -1, which is really an exponent of -1, which makes that the denominator, right? Think about this really having a -1 right there. So we need to put a parentheses on this because the entire thing is on the denominator. And I'll explain what would be wrong if I didn't in a minute. So this would now become log of x, and this would become log of x plus 1. And then this whole thing would then just drop down, kind of left it there. Don't forget about your stuff that you didn't quite finish. So that 1/3 log base 2 of x would be there. Don't forget, if this is 2, I lost my 2's here. We're going to want to make sure they all match. And the reason I noticed that is I went back at the beginning. Oh, there's a 2. So just make sure at the end, you check all your problems, log 4. This is log base 10, evidently, and make sure that you have the same log base as the beginning. Okay, so this is the answer. And I will say it might make more sense if we basically, this is correct, but if I distribute this, let me explain why that'll make sense from the beginning problem. Okay, so if I take a look at this and I have negative log base 2 of x and then minus log base 2 of x plus 1, you should think about it like this. This was on the numerator. These two things were on the denominator. And if I go back and check, that makes sense. If this was a plus right here, that would say that I had x plus 1 on the numerator, which isn't true. So I would analyze these like that. Like if you analyze, I mean, this one's all the top, but if you come back and look at this one, the question is, if I say this is my numerator and this is my denominator because it's negative, does that match? It does. This one doesn't have a denominator, so maybe it's not as important, right? And the question up here is this my numerator and the -1 my denominator? That analysis will really help you because if you accidentally put a plus here, that would be numerator. obviously more important when you have more than one thing. But that analysis is super helpful to not make a careless negative error, which we all know is the number one error people make on math problems.